Okay, welcome back, Swell Academy students. Today we're talking about converting between logarithmic and exponential. I don't want to get too much into what is a logarithm and how do we derive the exponential form from a logarithm and vice versa, and the uses and applications. I basically just want to provide you with a guideline, set of tools, basically a key to converting between the two as we solve for exponential functions and logarithmic functions, etc. The most important big piece here is this idea of log b x is equal to y. Here you have a base, you have your exponent, and this is logarithmic form that you're dealing with here. This is your log form, as we'll call it. And to convert to exponential, you simply have b to the y is equal to x. This is your conversion key here. This is your expo form. Now, if you have a problem that has log x equal to y, we're assuming that this lack of base here, we're assuming that it is your log 10, your log base 10. So if you're missing that piece, you're looking for a 10. Again, I'm just trying to provide you with a key. And then if you have a logarithm of Euler's number, basically we're creating a natural logarithm here. So if you see this, you can convert the log base e to a natural logarithm. These are some key pieces. Now some examples that could help. One, we'll look at just a simple example with, what if we had log base 8 of 64, and we're saying, well, what is that equal to? We could even do some process of thinking here and just look at this. We're dealing with exponents. Well, if I'm looking at 8 and 64 in that relationship, something pops in my head and says, okay, well, isn't 8 squared 64? And this is the relationship basically between a logarithm and how you could use this to find missing exponents. But again, I don't want to get to that. But this does help us, if I were to put a 2 here, relate back to our key where we have, oh, dropped a piece of my headphone there, where we have a b, an x, and a y, and that converts to a b to a y is equal to x. And this is your conversion here. Now you also have the example where we look at this natural logarithm where you have a line of 6, natural logarithm of 6 equal to 1.792, let's say. And we want to convert this. This is in logarithm form. We want to convert this to exponential form. And the first thing we think of, well, I know a natural logarithm of 6 is really a log base e. So I can say log base e of 6 is equal to 1.792. I do this to help me remember this little key piece here and kind of come up with a conversion of b to the x is equal to y, where I will have e to the 1.792 equal to 6, and I'm able to convert to expo form and basically having my b to the y equal to my x. So just a couple key pieces, a couple nice little examples here to help you with some conversion. I think from here we could start to get into what is a logarithm, its derivation, how it can be used. Because eventually we want to use a function where the variable's in the exponent and we want to put in certain values and find, okay, well, what is that x going to be in order to achieve these values. So remember, hard work beats failure, and I hope this is helpful. Have a good one.